So yeah, welcome to my talk. I'm going to talk about asset fuse. Asset fuse is a fuse file system that we wrote at Tweag, and it allows you to optimize for very large files that you want to feed into Bazel or Buck2. So first of all, I want you to think about this setup. You have your build system, Bazel, and you have a remote cache, and you have remote executors. But you have a CI where the CI runners are ephemeral. So the Bazel output base is not preserved, and the Bazel server itself is also not preserved. You may think that because you use remote execution that this is still fast, but in practice you will see that things like repository rules still need to rerun in this setup. So this can be very slow if you have repository rules that create large files as outputs. And yeah, in the rest of the talk I will talk about why this is a problem, why exactly this is slow, and an interesting way of working around this. So what you see here is the model that build systems like Bazel and Buck2 are modeled around. So the smallest unit that you can work with is an action, and an action just turns inputs into outputs. In this case, you have your command line arguments, your environment variables, and you have this set of input files. And the important thing to notice here is that the input files, they need to be hashed to be passed into this Merkle tree structure, which in the end gets included into this action message, which gets hashed again and then sent over for remote execution. So when you want to run an action in remote execution, you need to hash all of the input files at some point. Then there's another concept that's important. In Bazel, you have two kinds of files. You have source files that have no generating actions. So these just exist on the file system in advance. And then you have generated files marked in blue here. And these are the outputs of other actions. And now you may think, so what about repositories that are not the root repository? They also have source files, but they don't have a generating action. Where do they come from? And the answer is they come from repository rules. So you have your root module that just has source files that are on disk. It's pretty clear the source files already exist and Bazel can see them. And then there are other modules and repositories, and these can be instantiated using repository rules. And the important thing to note here is whenever you want to depend on a target from another repository, Bazel needs to actually materialize this repository in order to analyze the build files inside of that repository. And that happens in the loading phase. And yeah, the important thing here is the repository rule is a single unit, and it's not, you cannot break it down. So Bazel needs to run the whole repository rule to materialize the files just so they can analyze the build files so you can use them. So this can be very expensive for large repositories. So if you want to run an action remotely, I already said it before, but just to make this very clear, you need to calculate the action digest, and then you can check in the remote cache whether or not the action was already executed before. If not, then yeah, of course, the inputs need to be in the remote cache, and then you can run the action. But yeah, the important part is you need to calculate the action digest. And if we think about the action message again, we need to calculate the hashes of all of the files that go into the action. And for that, you need to hash the file contents. And Bazel has a very nice trick where you can either just read the file from front to back and calculate the hash, or you can opt into an optimization where you check for a specific extended attribute, and if it is set, then you can just read that instead of reading the whole file. And what this means is in practice, when you have remote execution, the files from these external repositories, they don't actually need to be there on disk. And Bazel doesn't actually need to read them. Bazel just needs to do this extended attribute check to get the digest. And it will never actually look at the source files in any other way. So from this, we get to a concrete problem statement. Repositories need to be completely materialized in a repository rule. This is bad, and it kills build without the bytes. For the source files in repositories, you cannot just avoid doing it. It all needs to happen on the machine where Bazel runs. The build files need to exist so that Bazel can analyze them. And all of this is kind of pointless because for remote execution, these source files only need to exist in the remote cache. Now there's one more building block. It's the remote asset API. It's part of the remote execution spec, and it defines a way where you can fetch a blob. You send a request to this endpoint, and you tell it, hey, I want this file. Here's a URI where you can fetch it from the internet, and here's an expected hash. And then the remote, the implementation, the fetch service can then fetch it from the internet, store it in the content addressable storage, and give you back the digest. And then later on, you can actually read the data from the content addressable storage. So this brings me to the architecture of asset views. You have Bazel or Buck2, and then you have this custom views file system that Bazel can read from. This file system can talk to your Bazel remote cache, and the remote cache can fetch files from the internet. Asset views uses a manifest that just stores the paths that you want to exist in the file system, along with the expected hash of those files and their sizes. And then there are some ways to specify where to get the files from, so the source. That brings me to the way that the file system works. So if the user space wants to read a file, it will send a read system call to the views file system. The file system can then send a fetch request to the remote asset API. This will then ensure that the file exists in the remote cache by downloading it from the internet. And then we get back the digest, and then the views file system can download parts of the file from the remote cache and return them to user space. And the other optimization is if we just need to get the digest of the file using the extended attribute, we can just load the blob in the background using the fetch API, but we can immediately return the digest back to the user space. So the file never needs to be downloaded to the local machine. So this brings us to some kind of comparison. So this is a bit like Git LFS on steroids. Git LFS allows you to store very large files outside of Git and instead have a little manifest that describes the data using a hash and a source, also the size of the blob. And then later you can download these files using some plugins to Git. And similarly, there's things like data version control that do the same thing in the end. You store the hash of the file and the source, and then later you can get the file. And they are not stored in Git. And with asset views, you also have this manifest, so it's pretty similar in that regard. But it's different in another regard, which is Git LFS and DVC both need to materialize these files ahead of time. So you need to say, download all of these files and make them available locally. Whereas with asset views, you just mount the file system and it happens immediately, and then the file contents get loaded lazily. So in the end, you have this structure where you have your build tool, Bazel or Buck2, connected to the remote cache, and you also have asset views, the file system, that is connected to the same backend. And asset views can preload the files into the remote cache, which are then available for remote execution. So this is, the benefits are quite clear. When you have large files, they can be prefetched, and the files never need to be available locally. So you can work with very large files very quickly. Yeah. There are a lot of other Fuse implementations that are relevant. I'm running out of time, so I will skip over this a little bit. BuildBarn also uses Fuse extensively, using for BB client D, for example. So the ideas are not new, but we are remixing them in a new way. Then there are some other things we would like to do in the future, like fetching full directories, like tar files and Git repositories, improve caching, and using things like Git LFS as a data source or some other formats. And now the most important thing is, in practice, this is no longer relevant, because with Bazel 9, Fabian added the experimental remote repo contents cache, and this will make repository rules cacheable in a remote cache, so you don't need to use these hacks like a custom file system. So yeah, thank you very much, Fabian. It is still a very interesting experiment, but I would like to say this is a better solution. So thank you very much for the time, and yeah, that's my talk.